So I've got here an example from the last video where I had 39 marks as the x value for an average marks of 30 and a standard deviation of 7. And I used this formula to calculate the probability of students scoring less than 39 marks, and that turned out to be 0.9. Well, the corresponding z value for this 39 turns out to be 1.29, and this is rounded off to 2 decimal places. And since it is rounded off, the probability that turns out to be is 0.90. It's slightly different in the third decimal place, but at least up to 2 decimal places they are the same. And they should be the same. It's just the two formulas are different. Notice this on the right hand side has norm S dist. It's for the standard normal, and it uses the z value to calculate probabilities. So now you had two formulas. The one on the left hand side that does not use z value, it uses the x value. So you plug in 39 marks for an average of 30 marks for a standard deviation of 7 marks. And you use this right away to directly calculate the probability. But if you have a z-score with you, then you could use the norm S dist formula to plug in the z-score and get the probability right away. So you have these two formulas. What I'm going to talk about now is that suppose you have this probability of 0.9. Could you use this probability to find out the z value or in the corresponding x value? So basically from 39 to 0.9 this is something that we already did, or the z value from 1.29 to 0.9 is something that we know how to do using these formulas. What we are trying to do is go back from 0.9 to the z value of 1.29, or go back from 0.9 to the x value of 39 marks. And for that, we have the inverse formulas. We use them like this here on the right hand side. So you see norm.inv inverse, and if you plug in the probability, which is 0.9007 right here, if you plug in this probability and you specify the mean of 30 marks and the standard deviation of 7 marks, it gives you an answer of 39 marks. So it tells you the probability of students scoring less than 39 marks was 0.9, but you've specified probability now, so it tells you that for a probability somebody scores for a probability of 0.9, the score that you would need would be 39. Okay, so this is one way to get back the x value from the probabilities. And you could also use this formula, the norm S inverse. Notice the difference is there's an S in between because this is using for the standard normal. So norm S inverse just requires the probability alone, and it gives you the corresponding z value. So key observation here is that now you can get the z value or the x value using the inverse formulas. So we have done both things. We have had x values and the z values, and we can calculate probabilities. And if we have these probabilities, we can always go back and obtain our corresponding x and z values.